Chapter 8, Section 1, we are solving systems of equations. Now the word system means more than one, so we're looking at solving more than one equation at a time. So we're going to look specifically at how to solve two equations with two unknowns, and then we'll move on to three equations with three unknowns. Now to solve two equations with two unknowns, there are three methods that you should be familiar with. The first method is the graphing method. And that method is fine as long as you have something to actually draw the graph for you, like a graphing calculator or possibly a computer. Because when you start having answers that are fractions or decimals, it's very hard for a handmade graph to give you those answers. The other two methods work every time. You've got the addition method. Some people call it the elimination method. And then you also have the substitution method. We'll be concentrating on those two methods since they are way more reliable than the graphing method. So if you'll look at this system of equation, you've got two equations with two unknowns, and let's work this using the addition or the elimination method. Now, to use the addition or the elimination method, what you're wanting is one of your variables to have opposite coefficients. That is, if you have a 2x, you want a negative 2x. If you have a 3y, you want a negative 3y. And if you'll notice in this problem, we do have a variable that has opposite coefficients, and it is our y's. So if we have that, we're going to add our two equations. 2x plus x, of course, is 3x. Negative y plus y, since those were opposite coefficients, they would add to be 0, or in other words, they would be eliminated. That's where the other name comes from. And then 1 plus 5 is 6. And when you add them, you're left with a very simple linear equation to solve. Dividing both sides by 3, we would get x is equal to 2. Now, taking that 2, we can plug it in for x in either equation, it does not matter which one, to find the corresponding y value. So I'll just put it in this bottom equation. If I let x be 2, I can solve for y by subtracting 2 from both sides, and that would give us y is equal to 3. So now remember, these are two lines. What we have just found is the one point that they cross or intersect, and it is the ordered pair 2, 3. Alright, if we're using the addition or elimination method for this problem, if you'll notice that we do not have a variable that has opposite coefficients. If we're in a situation like this, then we're going to have to figure out some number that we can multiply the top equation or bottom equation or possibly both equations by to make ourselves have these opposite coefficients. Now, looking at your x's, 7 and 5, I guess we could multiply 1 by 7 and 1 by negative 5, but the easier way would be to make the y's opposite. Because if you'll notice, if you multiply the top equation by 2, that's going to give you a positive 6y, and you already have a negative 6y in the bottom. So the easier method, not the only method, but the easier method would be to multiply the top by 2. So multiplying by 2, make sure you multiply everything by 2, and leaving that second equation alone, we would get 17x is equal to negative 34. Dividing both sides by 17, you would get x is equal to negative 2. And just like before, you can solve for y by taking that negative 2 and plugging it back into either equation. I'll just plug it into the top. So we'd get negative 10 plus 3y is equal to negative 7. Add 10 to both sides and divide by 3. We would get y is equal to 1. So our answer would be the ordered pair, negative 2 and 1. Now the other method that we said we would look at is the substitution method. And when you use the substitution method, you're going to want to rewrite one of your equations for one of your variables. Now my suggestion would be to pick the variable that has a leading coefficient of 1. That way you don't have to divide to get the variable by itself, and you won't have any fractions. So we have three choices here. We could solve for the x or the y up top, or the y in the second equation, because all of them have a coefficient of 1. I'll just take the top equation and solve it for x. So solving solving for x, I would need to move the y to the other side, and it would become negative y. We're going to take this and plug it into the other equation for x. So that means my second equation would now become 2, not times x anymore, but what we found x to be, which was that 5 minus y is equal to 4. Using our distributive property, combining like terms, we can subtract 10 from both sides and divide by negative 3, and we would get y is equal to 2. Now, just like before, we can take whatever we find and substitute it in to find the other variable. Now, what you're going to find, though, is when you're using the substitution method, the easiest place to plug in would be the rewritten equation. So if I take my rewritten equation and change my y to a 2, that's going to give me x is equal to 3. And again, the answer would be the ordered pair. Remember, ordered pairs have to be x then y. Doesn't matter which order you solve them in. Ordered pairs are x and y, so my answer would be 3, 2. Now, thinking about all the possible answers that we could get when we're solving our systems of equations. Right now, we're working on linear equations. You know that graph's to be a line. Lines can cross at one point, which is what we've been getting so far. This is what we call consistent. We could have a system that's inconsistent. That means they have no solution. That would be that they're parallel lines. And then we also could have a dependent system. A system that has infinite solutions, which basically means the two lines are exactly the same. Now, you're not going to be able to tell this until you actually start working out the problem. So let's look at this next example. Using any method you want, probably the easiest method would be the addition method. I could multiply the top by 2 and have opposite coefficients. So if I take and multiply the top by 2, we would have 2x plus 6y is equal to 8. Leaving the bottom alone, we would add 2x plus negative 2x is 0, 6y plus negative 6y is 0 also, and then 8 plus 3 is 11. Now notice what happened. Both the x and the y is eliminated, and you're left with just a statement. When this happens, you're going to have to look at your statement and decide if it's a true statement or a false statement. Well, in our case, 0 does not equal to 11, so it is a false statement. If it is a false statement, that means that there is no solution, which means that they are parallel lines. They don't have any points in common, which that would tell us that this is an inconsistent system. Looking at this next one. Again, probably the easiest way to solve this would be the addition or elimination method. I could multiply the top equation by negative 3, leaving the bottom equation alone. And when we go through and add, you should see you get 0 is equal to 0. Well, again, the x and y's eliminate. You're left this time with a true statement. That means they have all points in common, or in other words, the lines overlap each other, and this would be a dependent solution. Now, we're going to use the methods that we talked about for a 2x2 to expand to 3 equations and 3 variables. First step, you're going to pick 2 pairs of equations and eliminate the same variable from each pair. That will leave you with 2 equations with 2 unknowns, and you'll solve those using the method of your choice. And then once you solve those, you'll know 2 of the 3 variables, so you'll plug in to get the third variable. Alright, so looking at our example here, first thing we need to do is decide what variable to eliminate. It's totally up to you, your choice. I'm going to eliminate the z. Alright, now I'm going to work with equation 1 and equation 3 starting off, because if you'll notice, the z value values in equation 1 and 3 are already opposite, so I'm not going to have to do any additional work. So equation 1 is 3x plus 2y plus z is equal to 25. Equation 2 is x plus 4y minus z is equal to 11. If I want to eliminate the z's, they're already opposite, so when I add, I would get 4x plus 6y is equal to 36. Now I want to do that again for another pair of equations. Now there's not any other pair that would be as easy as those, but if you'll notice, if we look at equation 2 and 3, they are almost opposite. All we would have to do is multiply equation 3 by a 2, and it would become opposite. So I'm going to leave equation 2 just like it is, and I'm going to take equation 3 multiplied by 2 all the way through, and then add them together. So we would get 4x plus 5y equals 34. Now notice what we have here. We have got two equations with two variables. We're going to take those two equations and two variables and solve them using the method of our choice. So our first equation, if you'll remember, was 4x plus 6y is equal to 36. The second one was 4x plus 5y is equal to 34. I can use the addition method for the x's, but if you'll notice, they're both positive, so I need to go through and multiply one of these equations by a negative, so I'm just going to multiply the bottom one. So that basically means everything's going to turn into a negative, and we would get the x's to eliminate. We would be left with y is equal to 2. Remember, to solve for the other variable, you take whatever you come up with and plug it into either equation. I'll just plug it into the top. 6 times 2 is 12. Subtracting 12 from both sides, we get 24. So that tells us x is equal to 6. So by solving the 2 by 2, I know that y is equal to 2. I know x is equal to 6. And I can take those two values and plug it into any one of the three original problems and find that third variable. So I'll just use that last equation. That last equation, if you'll remember, said x plus 4y minus z is equal to 11. Well, we now know that x is 6. We now know that y is 2. So all we have left to do is find z. So 6 plus 8 minus z is equal to 11. That would be 14 minus z is equal to 11. So z must be 3. So now we have it all. We know all three variables. Our answer must be in alphabetical order. So our answer would be 6, 2, and 3. Let's try one more. Looking at this example, this time, let's eliminate the y value. Remember, it's your choice. You just have to do it from two pairs of equations. If I choose to take equation 1 and equation 3 to eliminate the y's are already opposite, so nothing has to be multiplied. So I'm going to take equation 1, I'm going to take equation 3, and add them together. When I do that, I get x plus 3z is equal to 9. Now I need to do this for another pair of equations. This time I'll take equation 1 and equation 2, but those are not quite opposite. I need to multiply that top equation by 2. So multiplying all the way through by 2, leaving that second equation alone. The y's are opposite, and when we add, we get 10x plus 7z is equal to a negative 25. Now remember, we're going to take those two equations and solve them as two equations with two unknowns with any method you want. Well, looking at my two equations, it looks like that I can do the elimination method again, but to do that I would have to multiply the top equation by negative 10. So multiplying that top equation by negative 10, we would get negative 10x minus 30z is equal to negative 90. Leaving that second equation just like it is, the x's eliminate. We get negative 23z is equal to a negative 115. Dividing both sides by negative 23, you're going to get that z is equal to 5. Now remember, once you get one, you can get the other by simply plugging in. Letting z be 5 in that top equation, we'd get x plus 15 is equal to 9. Subtracting 15 from both sides, we would get x is equal to negative 6. And now that we have 2 of the 3, we'll go back to the original problem, pick an equation to plug into, and find the remaining variable. So I'll just take my x and z and plug it back into the top equation. Letting x be negative 6, we would get negative 24 plus y plus 5 for z is equal to negative 16. So y is going to be negative 16 plus 24 minus 5. Y would be 3. So now remember how to write your answer. It has to be in alphabetical order. So your answer would be x, which was negative 6, then y, which is 3, and then z, which is 5.